Good morning, everyone. I am Professor Nadish Pandey from Technocrats Institute of Technology, Bhopal, and I am going to discuss the subject engineering physics and its application. But this subject had two parts. First is engineering physics, but its application part we have to discuss about the engineering mechanics portion, and mechanics portion is very important for the practical prospects. So the first topic of this subject is center of gravity. So center of gravity, basically there are two terms, basically center of gravity and centroid. The center of gravity term is introduced for the 3D bodies, and centroid, that technical term, is introduced for the 2D bodies. So for the definition, center of gravity, the point through which the whole weight of the body acts irrespective of its position, is known as center of gravity. So a point where the body's whole weight is concentrated is called center of gravity. And every body has one and only one center of gravity. Every body have only one center of gravity, and that does not change accord irrespective of its position. Centroid, the plane figures like triangle, rectangle, circle, and etc. have only areas but no mass. The center of area of such figure is known as centroid. So simple, the plane figure center is called centroid, and 3D figures which have mass but no area is called center of gravity. We Now we are going to discuss about the methods for the center of gravity, for finding the how to find the center of gravity. So the first method is by geometrical consideration, the second one is by movements, and the third one is by graphical method. So we have to discuss about the first method, center of gravity by geometrical considerations. So in this topic we have to discuss about some type of figures which geometry is well defined, like rectangle, triangles, circles, and their center of gravities are known. How do we find the this topic? Consider it. The first is the center of gravity of a uniform rod is at its middle point. So uniform rod means a rod which have uniform shape is and the center of gravity of that rod is its middle point. Second point is the center of gravity of the rectangle or parallelogram is at the point where its diagonals meet, or the half of the length and width of the section. So in this figure we have to B is the width, and B by 2 and L by 2, that point is called the center of gravity of that rectangle or parallelogram. The third one is the center of gravity of a triangle. The center of gravity of a triangle where its medians meet, and medians is the point which bisect the line of the triangle and meets the frontal vertex of the triangle. So where the medians are meet is called center of gravity of a triangle, and medians where meet, the h is the height of triangle, so h by 3 is the medians meet. Now the fourth point is center of gravity of a trapezium. So if we have a trapezium with parallel sides A and B and the height is h, the center of gravity of the trapezium is h by 3 b plus 2a upon b plus a, according to the figure. The G point is called the center of gravity of the trapezium. Now the fifth point is center of gravity of a semicircle. Center of gravity of a semicircle is 4r by 3 pi, where r is the radius of the circle or semicircle. Sixth point is center of gravity of a circular sector making a semi-vertical angle alpha. So this is the circular sector, like pizza slice. The pizza and the slice is called circular sector, and the center of gravity of is the 2 by 3 r sine alpha by alpha. So this is the circular sector center of gravity. The seventh point is center of gravity of a cube is L by 2 from every face. Cube is a 3D figure, so I cannot define you by showing the figure because it's a 2D figure and we cannot make it in it's a 3D figure and we cannot make it in 2D. So cube, your room is like a cube if its sides are equal. So the center of gravity of the cube is L by 2, means if the length of your a wall is L, so L by 2 from every face. The next is center of gravity of a sphere. So center of gravity of a sphere means a ball is D by 2, where D is the diameter. So at the midpoint, okay. Ninth point is the center of gravity of a hemisphere. Hemisphere like a ball, katora. So the center of gravity of the ball is, that point is G, that is 3 by 8 from its base section. Is this is the ball and this point is called 3r by 8. The 10th point is the center of gravity of a right circular solid cone. In Hindi is called Shanku. So h by 4 is the right circular solid cone center of gravity. So I think this is clear. Next point is center of gravity by movements, the second method. So consider a figure like this and uh, of mass m whose center of gravity is required to be found out. Divide the body into small masses. We have to divide this body in small masses whose center of gravity are known. As shown in figure, let m1, m2, m3, m4 and etc. be the masses of the particle and x1, y1, x2, y2, x3, y3 be the coordinates of the center of gravity from the fixed point O. Like in this figure we can see. Let x bar and y bar be the coordinates of the center of gravity of the body. From the principle of movements, we know that mx bar will be equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 and so on. So we write m1 x1 plus m2 x2 is sigma mx and divide by m, where m is the m1 plus m2 plus m3, and similarly y bar is sigma my upon m. Now the center of gravity of a plane figure. Center of gravity of a plane figure, there is a formula. X bar will be equal to a1 x1 plus a2 x2 plus a3 x3 and so on, divide by a1 plus a2 plus a3. a1, a2, a3 is the small areas of that figure. With that we can divide the whole figure into small areas. That is, small areas is denoted by a1, a2, a3 and so on. And y bar is also a1 y1, a2 y2, a3 y3. Okay. And how can we apply this formula? We are going to discuss about with a numerical. Now first we have to discuss about the axis of reference, because we have to find the length where we have to find the x bar and y bar. So center of gravity of a body is always calculated with the reference of some assumed axis known as the axis of reference. We generally take the lowest line of the figure for calculating y bar and left line of the figure for calculating x bar. These underline things lines you have to memorize. That lowest line for calculating y bar and left line of the figure for calculating x bar. Now the numerical. The center of gravity of a symmetrical section at the section where if we draw a line, that line have to divide the figure into two equal parts. So in this figure you just see the red line, y axis is the line which divides this figure into two equal parts. So y is the line, so we have to put the formula of y bar, not x bar. So y bar formula is a1 y1 plus a2 y2 divided by a1 plus a2. And is in this T section we are seeing two rectangles, the upper one and the lower one. So we have to find a1, that is area of the rectangle, and a2 area of the second rectangle. y1 is the center of gravity of the first rectangle, y2 is the second of center of gravity of the second rectangle. But we are going to discuss for the y, and in axis of reference we already seen that y is calculated from the lowest line of the figure. So here that red line, the underlined line, lowest line of the figure is the reference point. So we have to find all the length from here. So first is rectangle a1, 100 into 300, that is 3000 mm square, and y1, the center of gravity of the upper rectangle, is that point, and we have to calculate from the bottom of the figure. So 150 is the whole length, and divide it by 30 by 2. 30 is the length, that is half. Rectangle center of gravity we already know, so half of the line. So 150 minus 15 or 30 by 2 is 135 mm. And the second one is second rectangle. So the second rectangle length is 120 mm and width is 30 mm. So 30 into 120 is 3600 mm square, and y2 is the midpoint, that is 120 divided by 2, this is 60, and put the values in y bar. We have to calculate 94.1 mm is the answer. For calculation, you can use calculator, and calculator is the scientific calculator. You have to bring the scientific calculator for the classes. Okay. So next numerical, find the center of gravity of a channel section. This channel section, this is C section, and you can see that this C section is also the symmetry, but in x-axis. The x-axis is the line which divide the figure in two equal parts. So x bar, a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2. The upper rectangle where 1 is written, 50 into 15. The center of gravity is find from where? The left line of the figure, because there is x, not y. So you can find it by the left line of the figure. From left, this length is 50 and divide by 2. This is 25. And the second rectangle, this upper length is 30, lower length is 15, and in lower length is 15. So 100 minus 30 is 70 into 15. So 1050 mm square, and x2, that width is 15. So 7.5, half of that. The third rectangle is also put these values in x bar formula, and we get 17.8 mm is the answer of this question. Okay. And this is the figure which you have to practice in your house, and this is the homework for this. The upper rectangle, middle rectangle, and the last rectangle. This is also the symmetrical figure from the y-axis. Y-axis. So you have to find it from the bottom of the figure, and you can comment in this video's comment section for the answer of this. Okay. So try it and make this video count for the your examination purpose. This is the topic of the center of gravity for the section. For the 3D figure, uh, sometimes the this is the area. Okay. For the sometimes the 3D figure also come in to the places. So the formula is modified from a1 x1, where we have to find area, but in the 3D figures we have to find volume. Okay. The formula is the same, but we have to find the volume. So v1 x1 plus v2 x2 plus v3 x3 divided by v1 plus v2 v3. In 2D figures we have to find area, but in 3D figure we have to find volume, and the whole process is the same. Okay. So I think uh, you can understand the point center of gravity. So next lecture we are going to discuss more things about this, and goodbye, take care. If you have any doubt, just comment in this video, and I can try to resolve the your problems. Okay. Goodbye.